Hi there, this is Guided Practice 8. We're working on solving our inequalities from section 2.6. We're going to start off here with number 1, where we have a 3-part inequality. And I am solving for x. So that means the first thing I want to do is get rid of this 3 in the denominator. So let's multiply all 3 pieces by 3. When I do that, I'm going to get 3 times negative 2 gives me negative 6 on the left. My inequalities stay the same because 3 is a positive number. In the middle, those 3's cancel, and I just get the 4x plus 1. And on the right, 0 times 3 is still 0. Now, the next thing I want to do is get rid of the plus 1. So then I'm going to subtract 1 on all 3 sides of my inequality. Negative 6 minus 1 is negative 7, less than 4x, less than or equal to negative 1. Now I want to get rid of that 4, so let's divide everything by 4. And that's going to leave me with negative 7 over 4 is less than x is less than or equal to negative 1/4. Okay. Notice I didn't flip any inequalities because every time I multiplied or divided, I did so by a positive value. Then I want to go ahead and graph this. So my solution goes from negative 7/4 to negative 1/2. I want an open circle at the 7/4 because there's no or equal to, and I want a closed circle at the negative 1/2 because there is an or equal to right there. And I want the space between them because my x is between those two numbers. Okay. Okay, now on to number 2. For this one, we're going to go ahead and start out by distributing. Let's take care of all those in parentheses. That's going to give me 12x squared plus 10x less than, FOIL these, 3x times 4x gives you 12x squared. The outside, 3x times 1 is plus 3x. The inside, negative 2 times 4 will give you minus 8x. And negative 2 times positive 1 is negative 2. That's going to give me 12x squared plus 10x is less than 12x squared minus 5x minus 2. None of that changes anything with your inequality. Then I noticed, by the way, that there's a 12x squared on both sides, so let's subtract it and get rid of it. And then I'm going to move all my x's to the left, so I'm going to go ahead and add 5x to both sides. When I do that, the 12s go away, and I'm left with 15x on the left, and these two cancel, just negative 2 on the right. And again, I have not multiplied or divided by anything, so I don't need to reverse my inequality. Last thing I want to do is get rid of this 15, divide by 15 on both sides. So that's going to leave me with x is less than negative 2 over 15. I do not flip my inequality because I divided by a positive number. Let's quickly sketch our answer on a graph. So I'm going to put negative 2/15 in the middle of my line. And I'm going to use an open circle because there's no or equal to here. Okay, no or equal to, open circle. And then I want to be less than that, and less than is to the left. Less than is to the left. Less than is to the left. Again, this arrow points to the left, so that's consistent with what's going on my number line. Okay. All right, let's take a look at this one. 2x minus 5 is less than or equal to negative 2. Okay, now let's see if we can start this one off. So absolute value all by itself, so that's good. Inequality less than or equal to negative 2. Now, less than or equal to with an absolute value, which means I'm going between. I'm going between negative 2 and positive 2. Now, stick with me for a minute. Add 5 to all 3 sides. This is 3. Oops. 3 is less than or equal to 6x is less than or equal to 7. Divide by 6. In all 3 places. That's going to give us 1/2 is less than or equal to x is less than or equal to 7/6. Okay, now let's check this. Choose a number between 1/2 and 7/6. I do believe 1 fits in there. If we plug in 1 times 6 is 1, 1 minus 5 is, sorry, 1 times 6 is 6. 6 minus 5 is 1. Absolute value of 1 is 1. Is 1 less than or equal to negative 2? Uh-oh, it's not. So what did we do wrong? We followed all the procedures. Well, if you take a look at this, this part on this side is an absolute value. So it has to be positive. Okay. And over here, this is saying it has to be less than or equal to negative 2. Well, there are only negative numbers that are less than or equal to negative 2. So is there any way that an expression that is positive can be always negative? No. So this one's actually going to yield us no solutions. And we actually could have seen that right from the beginning, which is why I said hang in with me. Okay. If you have an inequality that's less than for absolute value and it's negative, then there's going to be no solution. Okay. Now, if anything were different, if that 2 were positive, or if I had greater than or equal to negative 2, then that would have been fine. Okay. And I would have had to adjust for that. But typically when you're talking about absolute values, you don't want negative numbers over here or it's going to create problems. Okay. So watch out for that. Here's one where it is going to give us an answer because we're less than or equal to a positive number. Okay, so we're going to start out here by putting this between. So our 2x plus 5 over 3 is going to be between negative 1 and 1. Okay, then we're going to solve like a normal inequality. So we're going to multiply everything by 3 to get negative 3 less than or equal to 2x plus 5 less than 3. Then we're going to get rid of this 5, so subtract 5. That's going to give me negative 8 is less than or equal to 2x is less than negative 2. And then let's divide everything by 2. Now I'm dividing by a positive number, so I don't have to flip my inequality. And I get negative 4 is less than or equal to x is less than or equal to negative 1. So if we graph that, we're going from negative 4 to negative 1. And at negative 4, it's a closed circle because of the or equal to. At negative 1, it's an open circle because it's strictly less than. And I want the space between. Okay. Now let's try to check some number in here. What if we check, I don't know, negative 2? If we go up here and check negative 2, negative 2 times 2 is negative 4. Negative 4 plus 5 is positive 1. 1 over 3 is 1/3. Absolute value of 1/3 is positive 1/3, and that is less than 1. Okay, so it does work. And then we'll tackle the practice problems in class.